Hello dear participants, I welcome you all here in this lecture number 34 today, and the title of today's lecture is partial correlation. As we all know that in the previous lecture number 33, we tried to understand the meaning of correlation, and also we tried to understand that how can we compute or obtain the correlation bivariate correlation value. In today's lecture, we are going to discuss partial correlation, and here are the objectives of today's lecture. First objective is to make you all familiar with the meaning of concept partial correlation. Second objective of today's lecture is to make you all familiar with the procedure to obtain partial correlation using MS Excel and SPSS. And once we all are comfortable with the procedure part, then we'll try to understand that how can we read and interpret the value which we have obtained using MS Excel and SPSS. So let me start this lecture with explaining you that why actually we need to go for the partial correlation and what is an issue with the bivariate correlation. As we all know that in the previous lecture, we tried to understand that how can we obtain or how to compute the bivariate correlation, and here are the same variables which we referred in the previous lecture, and here is the correlation value, that is 0.71. so this value represents us that there is a high degree positive correlation between these two variables, marks and salary. And if I go little further, then this strong correlation value could be the result of some other extraneous factors like IQ or age of respondent and etc. Suppose I am having different variables with me, and I have just considered two variables, marks and salary, and the values associated with marks and salary, they gives me the correlation value, that is 0.71. And this represents me that there is a very strong association between the values associated with marks and salary. But in actual, there are chances that the variables like IQ level or the variable like age of respondent, they affects the marks, they affects the values associated with salary, because there are different variables with us. Now in such circumstances, partial correlation becomes useful. What it means, that we'll try to understand with one example. Partial correlation allows us to compute correlation between two variables while controlling the effect of other additional variables without throwing out any of the data. Here we try to find out a specific association. So here in the partial correlation, we try to find out the specific association between two variables, factoring out the effect of other variable. What it means, suppose if I'm having three variables like marks, other is a salary, and third is a IQ level. Now whatever the values associated here in the marks and salary, they are influenced by this third variable, that is IQ. In the case of bivariate correlation, we only considers the values associated with these two variables, but in the partial correlation, we are going to consider this third variable IQ, which has in some way influence on these two variables, marks and salary. And what we are going to do here, we are going to control the values associated with this third variable IQ, and we'll try to find out the more specific correlation value between the marks and salary. How it works? Let's see with one example. For that, let me take you all to the MS Excel. So here is our worksheet with the three variables. Variable number 1 is marks, variable number 2 is salary, and variable number 3 is IQ. And as we all know that there are these three variables, and there is kind of a correlation between all these three. It means the marks and salary will find some correlation value. Salary and IQ, definitely there will be some kind of correlation between these two, and marks and IQ again there will be some kind of correlation between these three. All these three variables are associated with each other. Each variable influences the value of other variable. So this is the way that this data works. Now if I go further and if I compute three different correlations, how to compute bivariate correlation, that we already have seen in the previous lecture. Here the first correlation is between marks and salary. So if I I call this marks as a for salary if I mark it as a B, and for IQ if I mark it as a C, then the correlation between marks and salary is denoted by R for the correlation and AB for the respective columns. So A for marks, B for salary. So here the correlation between A and B, simple correlation, bivariate correlation, that we are going to compute. How to compute? This part already we have seen. We use a function correl in MS Excel. We put equal to sign and we use this function. I'll click on this and then first I'll select the values associated with the mark. So I'll just select these values. As I select this value, that range, it appears here. Then I'll put just comma and then I'll go to the salary and I'll select the values associated with salary. So here I have used this function and then I have just selected the values associated with marks. Then I put a equal to this comma and then I have selected the values associated with salary. Now as I press enter, I'll get the correlation value, and this value is actually near to 1. It explains us that there is a high degree positive correlation, and we already have talked on this in the previous lecture, that how to give meaning to this value. Fine. Now let me come to the second case. In the second case I'm going to compute correlation between salary and IQ. So salary, here it is denoted by B and IQ is denoted by C. So I'm going to compute the correlation between B and C. This R stands for correlation and B stands for salary and C stands for IQ. Procedure is same again. Here I am going to put equal to sign, then this function correl in MS Excel. Then I am going to select the range. So I'll select this range, salary, all these values I have just selected here. Then I put a comma and then I have selected the values associated with this IQ. Now simply I am going to compute the correlation between these two variables. That is why I am going to compute bivariate correlation value between these two. So the value which I'll get is 0.57. And if you look carefully, the first one is high degree positive correlation. The other, it seems to be like kind of low degree positive correlation. This is more than 0.5. So one can say that this is also high degree positive correlation. But if I compare the previous value compared to this value, this is lesser value. Fine. So the correlation between salary and IQ that we have got here. Now let me take you all to the third case, and the third case is correlation between IQ and marks. See, in the first case I have computed the correlation between marks and salary. In the second case I have computed the correlation between salary and IQ. Now in the third case I am going to compute correlation between marks and IQ, these two. Fine. And for that what I am going to do, simply I will put equal to sign, that function correl, then I will select the range, that is, this say that IQ level. I have selected this range first and then I have selected the range marks. Fine. For the marks, then I will simply press enter and I've got the correlation between the IQ and marks. Now I'm not going to interpret these values, because how to read and interpret the values associated with bivariate correlation, that part already we have discussed in the previous lecture. Here in the third case it seems to be a low degree positive correlation. Now let me take you to the partial correlation. What is partial correlation? See, the things are here the correlation between marks and salary considering only two variables, mark and salary, and the value associated here it is 0.71, high degree positive correlation. Now again if I write here partial correlation between marks and salary, now this is not bivariate correlation, this is partial correlation. marks and salary, because all these values, they are not only associated with each other, but they are associated with the values lied here in the IQ. Fine. So what we are going to do here in the partial correlation, we are going to control this variable. We are going to use this variable also here in a particular formula, and controlling IQ, what would be the pure association? What would be the correlation between marks and salary? That we are going to compute, and we'll check it that whether the simple correlation value and the partial correlation value between the same variable, whether it is same or different. Let's see that thing, and for that we need to use this formula. This formula we need to remember if we are going to compute partial correlation in MS Excel. So here in this formula, what is RB? RB is nothing but here this value is RB, and in MS Excel here it is G column and third row, and this G3 represents the correlation between A and B. A and B is nothing but the correlation value between marks and salary. So this is the simple means this formula. To make it simple, I have mentioned the respective cell, that is G3 for RB, G4 is nothing but that is RBC, RBC, and RBC is what is this? This is a correlation between salary and IQ. Salary, it stands here in the column B, and IQ stands here in the column C. And third, that is RAC. RAC is nothing but the correlation between IQ and marks and IQ. Fine, that is A and C. So this is the way that we have arranged all these things, and here is the formula. Now I'm going to type this formula here in this cell. In this cell, I'll put equal to sign. Then I need to give this bracket, and then I need to first select the RAB. RAB is nothing but the correlation value, bivariate correlation value of A and B column, that is marks and salary. Correlation of these two variables is given here, that is G column third row, that is by 0.71. So what I am going to do, simply I'll take my cursor here and I'll just click on this cell. I'll just click on this cell. As I click on this cell, this G3 it appears here. Then I'll put minus sign using my keyboard. Then I'll click on RAC. RAC is here, that is G5. The cell number is G5. I'll simply click here on this. Then I'll put this multiplication sign using my keyboard. Fine. So G5 multiplied by again G4. G5 multiplied by G4. G4 is RBC. Fine. Then I'll close the bracket. I'll give this division sign using my keyboard. Now there is one function SQRT, and that is the square root. That's the function that we use here in the MS Excel. Then again I'll give the bracket, and the next function or the next procedure is that I'll have to put 1. Then I'll press minus sign. Now R square AC. Now where is the AC? AC is located here. This is AC. And AC is nothing but G5. So what I'll do, I'll simply go to this cell and I'll click on this cell so that I'll get this G5. Now how to square it? Because here is the R square. How to square it? To square this G5, we are going to use our keyboard, and in the keyboard, if I press shift button and if I press the numeric number 6 on the top of my keyboard, then using shift plus numeric number 6, this sign, this cap will appear, and this cap is nothing but it is kind of a function which squares that particular this number, that is G5, this cell, it squares that cell. So I'll just place this hat here, and then I'll put number 2 for the square thing. Right? So this is the way we square any number. So G5 hat 2, then I'll close the bracket, then I'll put this multiplication sign using my keyboard. Again I'll start with one bracket, 1 minus r square bc. For that simply I'll click on this cell rbc, and that cell rbc is nothing but g4. Then I'll just put this cap here for the square, then I'll put number 2 and I'll close the bracket. So this is the way that we have to define the function. We have to define the function. Once we define the function, we'll simply press enter. Here is the function, here is the complete function. On the basis of this, we have just simply clicked on the respective cells, square root we have used this square kind of function also. And now if I press enter, I'll get the correlation value. Correlation between whom? Marks and salary. So here is the correlation between marks and salary, controlling IQ. Now if I compare this value with this value, then there is a difference. There is a difference. See, in both the cases there are two variables, marks and salary. The variables are same, marks and salary, correlation between marks and salary. But here in this case we only considered two variables without controlling anything, only two variables. But here we controlled other variable, assuming that that other variable affects the values associated here in the marks and salary. And if I control this IQ, controlling IQ, now I have got the accurate number, the accurate correlation of these two variables, marks and salary. Here also we have got 0.61. So this number represents that high degree positive correlation, but this number is little less than this number. This number is little less than this number. So this is the way that we use partial correlation, and this is the way that this is the reason that partial correlation plays a very important role in statistical analysis. So it was the part that it was there in the MS Excel. Now let me take you all to the SPSS. In the SPSS, how to compute or how to obtain partial correlation, and for that first we need to go to our data, we need to import our data. And for that first I'll go to the file, then I'll go to open, then I'll click on data, then I'll go to appropriate location where my worksheet is there, then I'll click on my respective worksheet and I'll click on open. Again I'll click on OK, and here is my data. My data is imported here in SPSS. Now the first thing that we should do always is that we should go to the variable view. I'll click on variable view, and here I need to redefine my variables. I need to put here all labels and all other things I'll have to check. Once everything is fine with my data, then I'll go back to data view. I'll click on data view, and now my data is ready for the treatment. So what we are going to do here, we are going to compute partial correlation. But before going to the partial correlation, let me first compute the correlation. First we'll get the correlation value, bivariate correlation. Then we'll go for the partial correlation, and then we'll compare the difference. So to compute bivariate correlation, simply I'll go to analyze, I'll go to correlation, and in this correlation we are having both the options, bivariate and partial. But first we'll compute bivariate and then we'll compute partial, and then we'll try to understand the difference between both. So simply I'll click on the bivariate. Now a new pop-up window comes. Here if you observe, we are having only one box where we need to put the two variables. For which variables we need to compute the correlation value. So what I'll do, I'll select these two variables. I'll put these two variables here in this variable box and I'll press OK. Here is my bivariate correlation value, and that value is 0.711. 0.77 is 0.711 between salary and marks. Fine. So it was the bivariate correlation. Now let me take you to the partial correlation. See, this strong correlation value could be the result of some other extraneous factor like IQ. There are chances that this value, that's fine that this value is there with us, but there are chances that there is some other variable like IQ, it has influence on this value. To control this, we need to go for the partial correlation. So what is the procedure here? In the SPSS, simply we'll go to analyze, we'll go to correlate, and instead of going to bivariate, we'll go for the partial. I'll click on the partial. Now new pop-up window comes, and here again we'll find two boxes now, variables and controlling for. So here is the box where we can put the variables for which we actually need to compute or need to obtain the correlation value, and here is the box where we'll put the variable which we are going to control for. Fine. Now from the variable list, I am going to place these two variables in which I am interested in here in the variables box, and I am going to put this variable here in the controlling for that box. So let me do that. So I'll select these two variables and I'll put in the variables box, and I'll click on this IQ and I'll put it here in the controlling for. Then simply I'll press on OK. As I click on OK, I'll get the value, partial correlation value, and this value is here, and this value is now 0.619. And this is a correlation between who? This is a correlation between, again, the salary and marks, controlling this IQ level. This is control variable, IQ level. Fine. So the marks and salary, the same variables, but we have got the different value, correlation value. Now, if I go further and if I compare both the values, in a simple bivariate correlation, the value is 0.711 between salary and marks. Here in the partial correlation, the value is 0.611 between salary and marks, controlling IQ level. So here is a big difference in actual. So if we are going for the analysis or the interpretation part, it is always better to go with the partial correlation controlling the other variables. Fine. It gives you the proper kind of interpretation. Now if I take you all to the this MS Excel comparison between the MS Excel output and SPSS output, we'll find that in both the cases the value is same, that is 0.61. So this partial correlation value is same though we are using the MS Excel or SPSS. So it is up to us that whatever software or whatever is the comfortable or accessible to us, we can go to that particular part like MS Excel and SPSS and we can compute partial correlation. No problem with that. So I hope that you all enjoyed this lecture and you all understood that how to compute or how to obtain the value for partial correlation, and I hope you all will utilize this concept in your research. So far this lecture is concerned, we'll stop here. See you soon in the next lecture. Thank you.